Okay, there will be example party, and as I said, I already sent an email to your mail and D12 email, and there is a QR code and the link to join to the exam prep party and the schedule for all exam prep parties. Good. So I'm gonna share my screen. Just you can scan this QR code. When you scan this QR code, okay, when you scan this QR code, it will take you to this page. Okay, so what you can do, if you would like to get update about anything that we will do in the learning comment and like the example party, you can subscribe or you can send an email. Okay, when you subscribe any update, okay, you will be notified for any update. For example party, this is not for the class, okay, this is extra resources, okay, that you can use. So the first link does show the physics example parties. And if you click this link, so you just need to look at the physics 120, September 14, 12:10 to 2 p.m. Where is the location for example party? TLC building, first floor in the mathematics and computer science city. And if you cannot attend in person, good, you can join online. The link to join online is available here, and also this link is available here as well. Link to join physics exam prep parties online. If you click this link, you would be able to join to the exam prep party online. Okay, so if you need, have an appointment, one-on-one appointment, okay, in the learning comment, you can just click this link, and this is gonna be my schedule, my working schedule in the learning comment. So again, if you are practicing prepping for the exam, I highly recommend to participate to the exam prep party. And also, if you still need more help, you can come to the learning comment. My schedule is available here. By clicking this, okay, you would be able to see my entire schedule in the learning. Sounds good? Okay, so okay, today we will be talking about Newton's law of motion. So, and before starting, okay, talking about the Newton's law of motion, and let's review what we have learned so far. We talked about the kinematic of motion, motion with the constant velocity and motion with the constant acceleration. Good. And we said that when the object is moving with the constant velocity, it means that its velocity doesn't change and it's moved with the zero acceleration. There is no acceleration. The object is moving with the constant velocity, and it means that the velocity doesn't change. If we graph the position versus time, the graph of position versus time change linearly, and also velocity versus time is going to be the straight line because the velocity doesn't change. And what is the acceleration? The acceleration is zero. So I would like to connect the kinematic of motion of the constant velocity to a dynamic. So let's say we will see in a nature that a particle is moving with the constant velocity. How we can analyze this motion, the dynamic of the motion. Good. So based on the Newton's first law, when the object is at rest, it will be at rest. If the object's moving with the constant velocity, it will move with constant velocity forever. If there is no force exerted, or if there are force exerted, these forces should cancel each other. This is going to be the Newton first law. What does it mean? It means that when the object is moving with the constant velocity, or if the object is at rest, if it's at rest, stay at rest. If it moves with the constant velocity, it will move with constant velocity forever if the net force are zero. What does it mean when the net force is zero? When the net force is zero, it means that no forces, yes? If there are forces, forces cancel each other, yep? We learned this, that this is a equilibrium, yep? Okay, so what was the equilibrium? What is the equilibrium? Equilibrium means that net force equals zero. We need to identify all forces in the system. Good. Like normal force, how many forces we have? We have a normal force, force of gravity, force of tension. What else we have? Force of friction, yes? And what?
The brake force?
So external or internal force, okay, like pushing or pulling forces. F push, F pull. Good? Yes, Fg is the force of gravity, okay? So we identify all these forces, and then sometimes these forces cancel each other, okay? Or there is no forces exerting on object, which is impossible. Definitely this force of gravity is exerting on all objects. Good? So this is going to be Newton first law. If the object is at rest, it will stay at rest. If the object moving with the constant velocity, move with constant velocity forever. What does it mean? It means that if the object is in equilibrium, kinetic equilibrium or static equilibrium. When the object is in equilibrium, when the net force is zero. Okay? So what does it mean when the object is at rest? Okay. For instance, we will have a box good, and there is a person who push in this box. We have a pushing force, external force, and there is a friction between the box and the ground. Okay, so the person is trying to push the box forward. There is a friction force. What would be the direction of the friction force? Opposite direction. Okay, how we can draw, okay, this direction force? There will be force, yes? We call it friction force. Okay? And we say that this system is not moving or moving with the constant velocity. Okay, the box move with V constant. What happening here? So do we have any other forces in a vertical? Force of gravity, let's draw the force of gravity as well. Okay, but sometimes the question says that you are pushing object and there is a friction, but it doesn't mention anything about the force of gravity or normal force. This is something that you need to identify. We call it identifying all forces which are exerted on an object of interest. Good? These two forces are not the only forces. We need to.
Several forces.
There are several forces. Good? So this is our job to identify these forces. Definitely you have seen in your practice review that there is a box, okay, there is any object and it's asking to calculate, or identify forces and find the value of the forces. Okay, so here our next job is to identify other forces. What are the other forces? No, inertia is not a force. Force of gravity.
The box is kind of back against.
No, that's something else. Okay, we will discuss about the Newton third law. Okay, we are still in Newton first law. Good?
The box resistance.
Yes, okay, we will talk later. So force of normal force, yes, and there is force of gravity. Okay? How we can analyze this? We can say that the box is moving with the constant velocity. What does it mean? The acceleration is 0. When the acceleration is 0, net force is 0. In all components, horizontal component, yes, horizontal and vertical, yes. So how many forces, horizontal forces we have? Two horizontal forces. Good. What are these two forces? F push. What is the direction of the F push? Positive or negative? Positive. Okay. Plus, what is the force of friction? Negative. I just showed with the negative. It should be equal to 0. Okay? Make sense? And what are the vertical forces? Fn positive or negative? Fn. Oh. Plus, what is the force of gravity direction? Down. Equals 0. Good. So, what I can say from these two, I can say that these two forces, force of push is equal to the force of friction, okay? And the normal force is equal to the force of gravity. Good? This is Newton first. There are forces, but these forces canceling each other. There are forces, but these forces canceling each other. So whenever you have a system, in the system, there are forces and these forces canceling each other and the net force is 0, there are two situations. If the object is at rest, is a stay at rest. For instance here, this mark is at rest. Stay at rest forever because forces cancel each other. Normal force and force of gravity cancel each other. A static equilibrium, perfect. If it was moving, definitely should move with the constant velocity. Make sense? If it's move, it move with the constant velocity. But the net force is still 0. That's the Newton first. Easy? So, let's move on to Newton's second law. I'll just explain all Newton's law first, okay? And then we will go over the PowerPoint. Any question? We kind of explained this, okay, a couple of times, okay, last week, okay, but I just wanted to because we are talking just about the Newton's law. I just wanted to remind you about the Newton's law one more time.
Refresh my memory.
Yeah.
Fn is the resistant force. It's
No,
normal.
no, no, normal force.
What's
The
difference?
support force. We call it normal force or support force. Whenever the object is on the surface, any surface, it can be a flat surface, it can be inclined surface. That surface always exert a force on the object, and that force is always perpendicular to the surface. For instance, ow. Let's say we have box on the ground. The ground is considered as a surface, yes? Definitely this ground is exerting a support force, or we call it support or normal. Support, I like support more, okay, because it's supporting the object. Yes? And this force is always perpendicular. What does it mean? It's always perpendicular on the surface. No, first, we are talking about the forces, okay? Okay, let's say you remember the card on incline? Good. Let's say we have an incline path and there is a box or card. So identify forces. How many forces are exerted? What is the Fn direction then?
Up.
Which direction? Up
Up.
means here?
Yes.
No.
Oh, it's against the perpendicular.
Perfect. It's perpendicular to the surface. So if this surface is here, yes, Fn is going to be perpendicular to the surface. Good? Again, normal force is the force which is exerted on the object by a surface that object is on it. And this force is always perpendicular. We call it support force or normal force. Perpendicular. And what other forces we have?
Gravity.
Perfect. Which is, let me just. Should be exactly toward to the ground. Good. Toward to the ground. And let's say if we have a friction, what would be the direction friction? The friction direction. If the cart moving down, okay, so the friction would be in the opposite direction, okay? So if I draw this, the friction will be, okay, if it's moving down. Good? This is a normal force. Okay, back to Newton's second law. Let me just let me just explain it in a word, okay, and then we will try to explain it in a physics form. Question? Question? You have a question?
Me?
Yeah.
No,
Oh, okay.
sorry. Just yawning.
Okay. Let's say again kinematic. With the velocity of the object increasing or decreasing. When it's increasing, speeding up. When it's decreasing, slowing down. Speeding up it happened in two situations. You are moving to the right side of the coordinate system, velocity and acceleration in the same direction. You are moving in the opposite direction of the coordinate system. Again, velocity and acceleration should be in the same direction. The first one, A and V positive. Second one, A and V is negative. This is a speeding up, a slowing down. You move forward, but your velocity is decreasing. The acceleration should be opposite direction. Good. And then you are moving to the left. Your velocity is negative, but your acceleration should be positive. We already draw a graph, position versus time, velocity versus time, and acceleration versus time. We know how the graph is going to look like. Good. Right now, analyzing a dynamic of the motion. Why the object is accelerating and why the object is decelerating? What do you think? It's force that causing the object or system of particles accelerate or decelerate. Good. So what is the Newton's second law? The Newton's second law is telling oh, when we have a box and if you are exerting a F push and this is box is accelerating and assume that there is a friction as well. Good. I can identify all forces. Again, like the last problem, we will try identify all forces. What are the forces we have?
Normal.
F normal, force of gravity, F push, and friction force. Yes? Okay. This object is accelerating in the horizontal direction. So what does it mean? It means that the box is moving through the x-axis, horizontal. In the y-axis, it doesn't move. Okay. When it doesn't move in the y-axis, what does it mean? Those forces in the y-axis, they are canceling each other. So normal force and force of gravity are equal because it's not moving up and down. Yes, it's moving just in the horizontal direction. What is telling that the object is accelerating? In the Newton's first law, it was moving, but moving with the constant velocity, or it was rest, but here is accelerating. So what does it mean? It means that F pushing is bigger than the friction force. That's why the object is accelerating. It means that the net force in the horizontal is not zero. When it's not zero, what does it mean? It means that F push is bigger than friction. When it's not zero, it means that it's equal to something. Yes? We just say that the sigma F is directly related to the mass of the system. And the sigma F is directly related to the acceleration. So by these two, let me just go to the next page. I can say sigma F is directly related to the mass. Sigma F is directly related to the acceleration. And we know that the sigma F is not zero. Yes? What does it mean? It means that sigma F is equal mass time acceleration. Newton second law of motion. Good. If the net force is not zero, definitely the object is accelerate or decelerate. Okay? If the net force is not zero, the object will accelerate or decelerate. This is going to be the Newton second. What does it mean? If you are pushing an object, pushing a force, or pulling a force, the object will accelerate. If the net force of the system is not zero, definitely the object will accelerate or decelerate. Good? If the acceleration and velocity in the same direction, it will accelerate. If the acceleration and velocity in the opposite direction, it's decelerate. Good? So this is Newton's second law. So, and how we can write the Newton's second law? Sigma F is equal mass time acceleration. We already know that the mass unit is kilogram, acceleration unit is meter per second squared, and the F unit is Newton. Yes? And the units are important. When you are using unit, okay, it's important to use the right unit. Okay, force are Newton, it doesn't matter. It's a tension force, force of gravity, normal force, friction force is always Newton. Acceleration is meter per second squared. Good. And the mass is kilogram. And we can write the acceleration. We can rewrite this formula. We can say acceleration is net force divided by mass. Yes? If you find the net force of the system and divide by mass, you can calculate the acceleration of that system. The acceleration of the system, it means that the acceleration in the direction of the motion. Yes? So, if I use this unit, okay, so let's say, what is the unit of the force? Newton. What is the unit of the mass? Kilogram. Yes? We can say acceleration unit is Newton per kilogram or meter per second squared. These two are same. So acceleration does have two units, meter per second squared or Newton per kilogram, based on this formula. Okay? Any question about this Newton second law? We will provide more example, okay, in the PowerPoint.
Is there a third way to write it? Solve for force on the top, solve for acceleration. How would we solve for that?
No, acceleration, okay, so how we can find the acceleration from here? You divide both sides by m, yes? M and m cancel each other. What is left is going to be net force divided by mass. Okay? What is the force unit? Newton. What is the mass unit? Kilogram. Newton per kilogram is the unit of the acceleration. Or we already know from the kinematic, which is meter per second squared as well. Why? Delta V over delta T. Yes? Meter per second divided by second is going to be meter per second squared. So acceleration has units, meter per second squared, or Newton per kilogram. When we are analyzing a dynamic of the motion, okay, so we use this unit, Newton per kilogram, because we are talking about forces. When we are talking about the kinematic of the motion, We use meter per second. We use time displacement. Okay? It depends how you are analyzing the motion of the object. With the kinematic or dynamic. Question? Okay. Now Newton's third law. Newton's third law. First thing which is important, always between two objects. If we have two objects, we can talk about the Newton's third law. So what is the Newton's third law? The Newton's third law is telling that if we have two objects, if object one, let's say we have two objects, two boxes, good, on the ground. If box one exert force on box two, good, box two will exert exactly the same force in the opposite direction. If we call this F12, this is going to be F21. What does the F12 means? It means that force which is exerted on box 2 by box 1. The box 1 exerting force on box 2, based on Newton's third law, the box 2 will exert exactly the same force, same magnitude, opposite direction. Okay? Example. Let's say there is a wall here and there is a person. This is a wall. And this person exerting push force. How many objects we have here? How many objects of interest we have? What are those two objects of interest? Person and wall. Good? Perfect. I have two objects based on the Newton's third law, which is important. Person is exerting pushing force on the wall. You remember Newton's third law? Object 1 exerting force on object 2, pushing. Object 2, which is the wall, exerting the same force on the person. Yep. F push. Good. Let me just draw a little better. Wall, person, okay? F push, and then the ball exerting the same force on the person, F push. If I separate these two, this is a person and this is a wall, what exactly happening? How I can identify forces separately? Person exerting force, F push, yes? And the wall exerting the same force but in the opposite direction, good? Because we have two objects, we need to identify forces on two objects separately. Do not put them together. That's why you get confused. Make sense? We have two objects. When we are on identifying forces, we have to identify forces on two objects separately. What you can do to make it easier, because they are close, just separate them from each other, okay? And then say that person exerting force on a wall, F push, based on the Newton's third law, the wall is exerting the same force on the person. How can I draw the forces? Like this. We have two objects. F push, F push. So there is a wall, yes? I hit the wall, yes? What exactly happened? You feel pain on your hand. Why? You are exerting force on a wall, the wall hit you back. Don't hit somebody.
Sorry.
Okay, so it is really important how we analyze the Newton's third law. Newton's third law is always happen when there is a contact between two or more than two objects. If force are being exerted to one object, that object exerts the same force on the first object. Yes? Exact same magnitude, but in the opposite direction. Okay. You remember we provide one example? Ground. Oh my. How we can write the ground? Ground. Good. And the person. Hmm? Normal force and gravity. Okay. Two objects, yes? Person and the ground. I would like to analyze this by Newton's third law. Good. So let me just draw a little better. Person. Okay. And the ground. Ground. And the person. You remember I said that it's better to separate. If you are identifying all forces, it's better to separate them. Yes? They are not separated, but it helps us to identify force better. Okay. What forces are exerted on the person? So you remember we said that normal, first start with the normal force. Okay, contact point, normal force. Good. So a person exerting normal force, sorry, ground is a surface, yes? Exerting normal force on a person, we call it Fn. Let me just write Fn. What is the Newton's third law? The person exerting exactly the same force on the ground. Okay? Equal and opposite direction. Yes or no? Is it clear? You remember we were talking about the person on the ground, okay? Because the object of interest was the person. We didn't care about the ground. But right now, both are important for us. We would like to identify both forces which are exerted on both, based on the Newton's third law. Ground exerting force on a person, the person exerting exactly the same force on the ground. Good? Any question? What other forces there was between the ground and the person? Force of gravity and friction. Let's talk about the, okay, gravity first. You know, the ground is exerting force of gravity on a person, yes? Force of gravity on a person. The ground is exerting force of the gravity on a person. The person exerts exactly the same force of gravity on the ground. Good. We will always show this one, okay, because the object of interest was a person. But based on Newton's third law that we learned, if they are analyzing two objects of interest, we need to identify, all forces for two objects of interest. Good? What is the last one? Friction. The reason that we can walk is because of the friction, yes? Good? So, you are moving forward. This person is moving, let's say, forward, yes? Move velocity is in this direction. What would be the friction force? Backward. The friction which is exerted on a person is going to be. How can I show it here? The friction is exerting on a person from the ground to the person. The person exerting exactly the same friction force to the ground, but in the opposite direction. Good? Now, what is the object of interest here? Sometimes you don't care about the Earth's movement, yes? What is important? The person movement. You just say these are the forces which are exerted on a person. But if the ground become important for you, you can say, there you go. These are the forces which are exerted on the ground by this person as well. Okay? You may say friction, friction. Why they are not canceling each other? Because this force is exerted on one object. They are separate object, yes? When we are calculating net force, you should calculate the net force on just one object. What is the net force of, what is this person? Let me just go to the next slide. We just say this is a person. What are the forces which is exerted on a person? Normal force, force of gravity, yes, and the friction. These are the forces that I analyze. What is the ground? We just draw the ground. The ground. What are the forces that exerted on the ground? Force of gravity, yes. And then friction. Okay. But why? I'm just using the motion of the person is important for me. Okay. These forces are important. When I'm writing Newton's second law, what was the Newton's second law? Sigma F equal mass time acceleration. Mass is just the mass of the person, not the mass of person and the ground. Okay? And the net force is the net for all forces which is exerted on person. Not all forces is exerted on person and the ground. Good? And acceleration of me just will be the acceleration of a person. So it means that we can write this equation for both. Okay, we can write this equation for both. Good? Why I am moving, but the earth is not moving? We said that, acceleration, this will have acceleration, this will have acceleration. I'm moving, right?
All of us are moving.
That's a relative motion. Okay, let's analyze this, okay? So a little bit more details, okay? Because when you learn this, okay, the rest will be just, just using the same analysis for any motion, for any forces. Good? So I just write this formula for each one separately. Acceleration of the ground, acceleration of the person is net forces on the person, yes, divided by mass of person, good. But the acceleration of the ground, I'm just using the same formula to write for the ground. Acceleration of the ground is going to be net forces again, these are exactly the same forces divided by mass of the ground, yes, or earth. You see here, these net forces are equal, yes? Yes or no? Same forces, yep. Mass of the person, mass of person is, let's say, 180 pounds. What is the mass of the ground? 1,000,000 times or 10,000 million times bigger than the person. You know, compare the acceleration of the person, yes, with the acceleration of the ground. The numerator is same, yes, the net forces, but the denominator are different. Mass of the person is much, much, much smaller than the mass of the ground. It means that the ground is moving because its mass is too big. The acceleration is gonna be very, 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 very a small number. Okay? And a small number, it means that acceleration is 0.0000000000001. It does have acceleration, but this acceleration is almost zero. Good? That's why we are moving, but the earth is moving, but you cannot notice. Newton's third law. See how important is the Newton's third law? If you have two objects of interest in the system, you need to analyze its motion. You need to identify forces on each object. Good. And then apply Newton's second law, which is the sigma F equal ma, or A equals sigma F equal m on each one separately. Make sense? Okay, perfect. So let's do 5 minutes break. Let's close this. Okay, right now we will talk about Newton's first. So we just explained the Newton's first law, yes, okay. And again, if object is moving with the constant velocity, if the object is at rest, it will stay at rest if the net forces are zero, or there are no forces exerted on the object. If there are forces, these forces cancel each other horizontally, vertically, and we will have equilibrium. Kinematic equilibrium or static equilibrium. Static equilibrium, it doesn't move, okay? Kinematic equilibrium is move. So we just explained about the Newton. Okay, some of these, okay, we already discussed. Okay, let's move on to, yes, equilibrium of the moving forces. And yes, okay. The Newton's second law of motion is telling that force cause acceleration. Force, acceleration. Acceleration, when the object is accelerating, definitely there is force that accelerating this object. You know, two way to analyze. When you look at the kinematic of the moving object, you will say, okay, this object is accelerating, this object is decelerating. Then we can say, okay, if it is accelerating or decelerating, definitely there are forces. And these forces cause the system get accelerate or decelerate. So, and the acceleration is directly related to the net force. The more force, see, acceleration is sigma F divided by m. Acceleration is directly related to the net force. More force, more acceleration. Less force, less acceleration. But the acceleration is inversely related to the mass. If you increase the mass, acceleration decreased. If you decrease the mass, acceleration increased. But we said in the Newton's third law, you remember? Earth and the person on the ground. the person is moving, the earth is almost moving, but it's not moving at all, okay? Because of the mass of the earth. Acceleration of the earth is inversely related to the mass of the earth because the mass is too big and they both receive the same net force. That's why the acceleration of the ground is almost zero because the mass of the earth is really, really, really big number. Okay? So here, as you can see in the example, you are exerting force on a block. If you double your force, the acceleration will double with two hands. One force, now two forces. Acceleration will double. If you double the force and double the mass, the acceleration stays same. Okay? So what was the acceleration here? Let's say F pushing divided by mass, yes? But what is the new acceleration here? How many forces we have here? If we have one F here, here is gonna be 2F, yes? 2F divided by M, okay? But here, we have still 2F, 1F, plus 1F is gonna be 2F. How many masses we have? Two masses. 2 and 2 cancel each other, is gonna be exactly the same as the first one. F divided by M. So mass inversely related to the acceleration and the force is directly related to acceleration. Increasing force, acceleration increase, decreasing force, acceleration decrease, increasing mass, acceleration decrease, decreasing mass, acceleration increase. This is the Newton's third law. Friction, we already talked about the friction. Good. No need to explain. Mass and weight, okay. We know that the weight, again, mass is a kilogram. Weight is the force of gravity. Yes? How we can calculate the force of gravity or weight of the object? By mass times gravitational acceleration. Good? This is how we can calculate the weight or force of gravity for any object. Force of gravity is weight. Weight is force of gravity. Okay? If my weight is the force that the earth is exerting on me, I call this force of gravity or my weight. Okay. Again, the same example, free fall. And you would like to calculate the acceleration of the free fall. We already know that the acceleration of the free fall is always g. Good. But here, you know, F divided by M, which is the force of gravity, mg, yes, divided by M is going to be g. Let's say you double this. When you doubling it, acceleration sigma F divided the mass total. When you're doubling this, okay, it means that you're doubling the weight. You're doubling the force of gravity, okay? 2F divided by how many mass we have? 2M. What was the F? We just said F force of gravity is mass times G. Yep. So if you have 2F, it means that you have 2mg. 2mg divided by 2m, 2m, 10, 2m cancel each other. G is going to be exactly the same. So it doesn't matter. It is a 1 Mach. It is 100 Mach. Based on the acceleration formula, net force divided by mass, yes, we will have the same acceleration. Okay? Why? What is the net force? The weight of 100 Mach. Yes? The weight of the 100 Mach divided by mass of the 100 Mach is going to be exactly the same gravitational acceleration. Okay, that's why if you drop this cell phone, it moves with the gravitational acceleration. If you drop this mug, it moves with the same gravitational acceleration. Okay, if there is no air resistive force, if there is no air resistance, if there is air resistance, that would be different story. Okay, we will talk later. Okay, non-free fall. Non-free fall means that when there is air resistance. Okay. So what is the air resistance? Air resistance, like a friction force, is a resistive force. If the object, when you're dropping the object, when there is air, the air is trying to oppose the motion of the particle. If this moving down, the force of gravity is pulling this down, there will be a force of resistance. We call it air resistant force, will be in the opposite direction of the motion. And these resistive force, I call it F resistive force, is directly related to the velocity. Or sometimes we call this R. R or FR. Okay, in some textbooks you just see as a FR or just R. R represents the resistance. This resistive force is directly related to the velocity. It means that it is not constant. The friction was constant, yes? But here, the resistive force is increasing with velocity. If the velocity of the particle increase, the resistive force increase. Okay. Let me just analyze air resistive force and this is a ground. This is an object. At the beginning, the velocity of this object is 0 and we have a non-free fall. What is the non-free fall? When there is a resistive force. We said that resistive force is directly related to the velocity. At the beginning, when it's about to release, what force we have? We are just talking about the forces which is exerted on the box or object, not the forces which is exerted on the ground, okay? No Newton's third law, just one object. Good? We are not talking about the action and reaction. Good? The object of interest here, just the dropping box, falling object. Okay, FG, let me just change the color. FG. Good? You remember I said the resistive force is directly related to the velocity. If you haven't dropped the object, there is a resistive force at the beginning, yes? The velocity is 0. 1 second later, let's draw this small. 1 second later, okay. What happened to the velocity? Let's say 1 second later we are here, yep? What is the velocity? The velocity can be any number, okay? Good, is not 0. Let's say it's not 0. How many forces we have? 2 forces. What are these 2 forces? Force of gravity and resistive force. Good. A small resistive force because the velocity just started increasing. Okay. 1 second, 2 seconds later. What is the object here? Let's say the object is here. Okay. Let me just. And what are the forces? Force of gravity is still same force. Good. But the resistive force is increasing. Why? Because the velocity has increased. When you drop the object, it is speeding up. So these resistive force increase until the force of gravity become equal to the resistive force. See, at the beginning, there is no resistive, yes? When you drop the resistive force changing with velocity, because the velocity increase, the resistive force, this vector is increasing until its magnitude become equal to the magnitude of the force of gravity. What happened at this situation? Let me just draw in the next page because there is no space. So let's say we have now the object at one point, the resistive force become equal to force of gravity. Yes? What exactly happened here at this point? What is the net force? What is the net force? 0. So net force become 0. What does it mean? It means that Fg become equal R because R was increasing. Yes? R was increasing with velocity. R is increase. At one point, the force of gravity become equal to the resistive force. So net force is 0. What is the Newton first law? If the object was at rest, it is stay at rest. If it's move with the constant velocity 4. We call this velocity, when the object reached at this point, we said that the object will moving with the constant velocity. We call this velocity terminal velocity. Here,
That's what I found.
okay, the velocity become constant, yes? Newton first law. Good. And then what does it mean? It means that we call this terminal velocity. Make sense? Yeah. Dynamic. That's why, it's at the beginning, the force of gravity. Resistive force increase until the resistive force become exactly equal to the force of gravity. At this point, these two forces, they cancel each other. Yep. When they cancel each other, what does it mean? Newton first law. When we are analyzing any motion, we should know Newton first law, Newton second law, Newton third law. Here, we don't care about the Newton third law because the object of interest is just the block, which is moving towards the ground. We don't need to analyze the motion of the ground. The object of interest is just moving particle toward to the ground. So Newton, first we started with the Newton's second law. Why? Because the only force which is exerted on object at the beginning was force of gravity. What is the net force? Is not 0. It means that the object is gonna move, yes? But 1 second later, force of gravity and air resistance. The net force is not 0, but the net force is smaller than the beginning. Force decreasing, the system, the acceleration gets smaller, yes? Acceleration at the beginning, let's go to here. Acceleration at the beginning here is G, good? At the very beginning. Because the only force which is exerted is what? Gravity, which is mg divided by m. Yes, m cancel each other, is going to be G. But here, what is the net force? R minus Fg, yes? or Fg minus R, it doesn't matter. Fg minus R divided by mass. Yep. What was the mg? Fg was mg minus R divided by m. Here mg divided by m is going to be g, but here mg minus R divided by m. Definitely this value is smaller than g. Yes? You know, g acceleration. There is an air resistive, the acceleration gets smaller until the last part. At this point, see, the acceleration is Fg minus R divided by M. What is the Fg minus R?
Gravity minus.
0. Yeah, because they are same. So this becomes 0, yes, divided by m, so the acceleration becomes 0. And it makes sense because the object moving with the terminal velocity, with the constant velocity, definitely the acceleration is 0. So what exactly is happening in the non-free fall? At the beginning, we have a gravitational acceleration g. As is moving toward to the ground, the acceleration decrease until it becomes 0. And when it becomes 0, the object moves with the constant velocity. Okay? This is how we analyze the motion of, the object. So let's parachute problem. How we can analyze this? A skydiver, okay? What exactly happening? Let's say you are just have you ever done this before? Has any, no one? Okay. Let's see what happens. You are in an airplane. You are trying to just do the skydiving. Good. You jump into the air. And at the very beginning, what force is exerting on you? Force of gravity. At the very beginning. And there is a air. Okay? When there is air, there is air resistance. The force of gravity is constant. Yes, it doesn't change. But the air resistance, as you're moving toward to the ground, your velocity increase. Increase until the force of gravity become equal to the force of resistance. So it means that you are decelerating until your velocity, until your net force becomes 0. The force of gravity and the air resistance becomes equal, yes? Or the net force becomes 0. At this point, the acceleration, there is no acceleration exerting on you. At the beginning was the gravitational acceleration decrease until become 0. And then you move with the constant velocity. At this point, let's say you're moving with the constant velocity for 10 seconds, you decide to open the parachute, yes? What happened?
Then you go up.
You go up. Why? Perfect. The surface area, air resistance is also directly related to the surface area. When the parachute was not open, okay? It was just a person, yes? What is the cross section of this person? A small value, yep? Let's say this small value. Now you open the parachute. It's gonna be, the cross section is gonna be like this, yeah? The force is exerting at the beginning on the mark, okay? Now you open the parachute, okay? The force is exerting on this object, yes? Because you open the parachute. The air resistance is directly related to the cross-section area. So the net force was 0, yes? When you have not opened the parachute, the net force was 0. Suddenly you open the parachute. What happened? the net force become really big number, even bigger than the force of gravity. You just move in the direction of the net force. What is the net force? The big R, yes, a small force of gravity. When you subtract these two, the net force is still gonna be upward. That's why when you open, you just move a little up, yes, for 2-3 seconds, 2 seconds, because the force of gravity, the air resistive force is much bigger than force of gravity at that point. And then what happened? When you are moving, okay, so this become equal, yes, as you are moving towards the ground. This become small, and until the force of gravity become equal to the new forces, air resistant force, okay? And then again, after that, you will reach to the terminal velocity. You will reach to the terminal velocity 2 times. When you have not opened the parachute, you will move until your force of gravity become equal to the air resistance. Good. And then open the parachute, you move up. Okay, you accelerate up, and then the force of gravity become, again, as you move down, the force of gravity become equal to the air resistive force. You move with, when the parachute is open, okay, you move with the second terminal velocity. Make sense? Okay. Yo, I think it is a good experience. Okay, I would like to do this, but I don't know. As I get older, okay, so it will be risky because of the heart problem. But okay. So we just do some example problem. Okay. We are almost done. Okay. But we do some example problem. And then if we have time, I just review the back and forth motion lab one more time because I have graded your report. Okay, I think you have seen. Okay, so and I just put some feedback for those who need the feedback, and I still think that some students still have problem, okay, with the back and forth motion, how to analyze it. So let's go over these problems first, and then we will try, if we have time, we will try to go over the back and forth motion lab one more time, okay, to answer those questions that we had in the back and forth. So what is the greatest acceleration a runner can master if the friction between her shoes and the pavement is 90% of the weight? Good. Do not jump into the formula. Draw the situation. Please, please. When you are solving any physics problem, try to draw the situation. Try to picture the problem. It's really helpful. So I don't jump to the formula because I know that the acceleration based on the Newton's second law, the acceleration is equal to net force divided by mass. Okay, I don't jump to the formula. I just read the problem one more time, try to draw the situation. What is this? Okay, there is a person. Good. And this person is walking on the ground. And I'm supposed to calculate what? Acceleration of what? A runner, not the acceleration of the ground, yes? Because we have two objects of interest here, a runner and the ground. But the question is telling that you don't need to worry about the ground, okay? So you just need to calculate the acceleration of the runner. So no Newton's third law, okay? For now. So I identify force which are exerted on a person. The ground is exerting force on a person, Fn. Again, I don't need to draw the reaction force which is exerted by person on the ground because I don't need to identify forces which are exerted on the ground. Yes, my object of interest is person. Make sense? Okay, what other forces is exerted on the person by the ground? Force of gravity. The person is moving forward, yes? So what does it mean? It means that the ground is exerting a friction force on a person. One more time, I would be able to draw the forces which is exerted on the ground based on the Newton's third law. Okay. But again, because the question is telling just calculate the acceleration of the runner, it doesn't mention anything about the ground. I don't need to identify forces which is exerted to the ground by the person. Good? But you know how to identify these forces. Good? Sounds good? Okay. When the person is running, moving, it doesn't go up and down. Normal force and force of gravity, they cancel each other. Fn and Fg cancel each other. It means that the net force vertical is 0. What is the horizontal? How many forces we have in the horizontal?
One.
What is that force? Just the friction. Good. And we are supposed to calculate them. So we don't have acceleration in vertical. So the vertical acceleration is 0, yes? The horizontal acceleration is the net force of the horizontal divided by mass of the person. Yep. What is the net force of the horizontal? Friction. Friction divided by mass. What is the question is telling? The friction is 90% of the person weights, yes? So it means that this friction is 90% of weight divided by mass, yes? So what is the weight formula? 90% of the weight is mg, good, divided by mass. Okay, so let me just change the color. Mass and mass cancel each other, so it's gonna be 90% of g. Yes, how we can solve this 90%? It means that we need to convert percentage to the decimal. What is the 90% means in decimal? 90 divided by 100, yes, which is going to be 0.9. 0.9 of g. We already have the g. G is 9.8 or 10. Good. So if we assume that the g is 10, let me just see. If we assume that the g is 10, so the acceleration is going to be 0.9 times 10, which is going to be 9 meter per second. Yep. Okay. So again, I draw the situation. I identified the force, normal force, force of gravity. They cancel each other. It means that I don't have acceleration in the vertical. And the only force which is exerted in the horizontal line, okay, is the friction force. So I can write the Newton's second law for the horizontal. Acceleration is going to be net force in the horizontal. All forces which is exerted on the person on the horizontal divided by mass of the person. The only force which is exerted on the horizontal is friction. And the question telling that this friction force value is 90% of the weight. We have the formula of the weight. Weight is mass times gravitational acceleration. Just do the calculation and then see how the step-by-step calculation when you are solving the problem make more sense when you go step by step. If you just jump into the formula, A equals sigma F divided by M. Okay, what is the sigma F? How should I find the sigma F? And in which direction? So how many forces I have? Because sigma F means net force, yes? Good. Example problem 6. I'll give you time, okay? We have the final solution, okay, but try to analyze. Draw the situation, good? Draw the situation and use the Newton first law, second law, if it is needed, Newton third law, and then many problem in the practice book and also in the homework. Again, what is the acceleration of a 20 kilogram pail of cement that is pulled upward? Let's say we have a pile of cement, yes? It is a 20 kilogram and is being pulled, yes? Let's say F pull. With a force of how much? 300 Newton. This is all information the question is giving. And it's telling that, the force is being, the force, is being pulled on the object, yes? The object is being pulled by this force. Okay, I just draw this. And next thing is identifying forces. How many forces will be exerted? What are those two forces? What is the next one then? Oh, okay. The pull here is already question is given. Okay, so it means that there is one. When we identify, because the question is telling that the force is being pulled. You already know that the question is helping you. We have one force already. We just draw this force. And the next thing that we need to do, we need to identify those forces that it is not given. The only force is being exerted based on this situation is the force of gravity. So right now, how many forces we have? Two forces, F pulling and gravity. Okay. Now applying Newton's law. We don't need the first law, okay? Because it's accelerating. The second law, we need it because the second law is talking about the acceleration. Acceleration is in the direction of the motion, which is the vertical acceleration, is the net force. All forces which is exerted in vertical divided by mass of the object. Yes? How many forces we have? We have positive F pulling, yes? Plus sigma means add. Plus, what is the force of gravity, positive or negative? Negative, because because when we don't use the vector, we need to use the positive or negative sign to show the direction. Good. So we here put negative Fg divided by mass of the cement, yes? Okay. So I already know that Fg is what? Mg or weight, yes? Let's calculate the FG first, okay? And I assume that the G is 10 meter per second squared, okay? I just rounded to the whole number. So FG will be what? What is the mass of the 20 kilogram time? What is the G? 10 meter per second squared, okay? 2 any time 10 is gonna be 200, perfect. 200 kilogram meter per second squared or 200 Newton. Yes? The other unit of the Newton is kilogram meter per second squared. You should know both Newtons or kilogram meter per second squared. Okay? So we will back to this equation. A is going to be equal. What is the F pool? Positive 300. Yes? See this positive? Positive 300 plus, what is the FG? 200, but we need to put negative. Divided by, what is the mass of the cement? 20. Okay? So, positive 3, positive 300, positive negative, negative. Yes? Negative 200 divided by 20. 100 divided by 20. 100 divided by 20 is going to be 5 meter per second squared or 5 Newton per kilogram. Yep. Meter per second squared. You know, I just summarized this here because I just wanted to show you how we are approaching to this number, how we are calculating. You need to do the same thing if you would like to learn. Identify all forces, try to get information from the problem. Identify forces and apply Newton's law. Sometimes you need to apply first law, second law, and third law, or all together in one problem. Is it clear? Any question about this problem? Okay. So let me just see example. Okay, let me just do these two more problem, okay? And then we will try to how much acceleration does a 744 jump jet of the mass of 30,000 kilogram experience in the takeoff when the thrust force of our engine is exactly 30,000 Newton? Yes? Again, how much acceleration does a 744 jump jet of a mass of 30,000 kilogram experience in the takeoff? Good. In takeoff when the thrust for each of the four engine is 30,000 Newton. Okay. Okay. Again, draw the situation. We have this jet. Good. Let me just draw. I was going to draw. Okay, this is a jumbo jet. Okay, so I cannot draw the jumbo jet, please. Let's say this is a jumbo jet.
Bullet train.
Okay, so So there are how many, four engines. Sometimes you miss this. That's why I'm telling you, okay, it's better to read the question with all details. Four engines, let's say we have one engine, two engine, three engine, and four engine. Good? And is telling that each one create a thrust force, yes? What was the thrust force? The fuel is burned. Good. Create a heat energy. Heat energy will push the airplane forward. Yes? So what kind of energy, what kind of force is being exerted on the airplane? Thrust force. Yes? Thrust force is pushing the airplane forward. How I can draw then? Let me just change the color. I can say this is the 1, 2, 3, 4. Yes? Each one is 30,000 Newton. Okay? So, do we have any other forces? Gravity. Okay. The question is not, is telling it's moving just forward. Yes? It's not moving up and down. What does it mean?
No.
There is air resistance. Force of gravity and air resistance, they are canceling each other. Yes? They are exactly equal. Okay? That's why this doesn't move up and down. Okay? It's just moving like this. These two forces, they are canceling each other. So again, identifying force is important. You don't need these forces here, but identifying force help you to understand the problem better. Good? So I'll just draw these two forces. Let me just use the green color. What are these two? Are resistive force, yes, and force of gravity. There is no acceleration upward or downward, okay? Let's say vertical. Acceleration is 0. What does it mean? The net force of vertical is 0. What does it mean? R and FG should be equal to each other, yes? So we didn't need it, but we analyzed it, okay? It's helping us to understand the problem better. Good? Okay, but we have acceleration in horizontal. A horizontal is what? The net forces in horizontal, yes, divided by mass of the jet, yes? How many forces we have here? 1, 2, 3, 4, yes? 4 multiplied by 30,000 Newton divided by, what is the mass of the airplane? 30,000 kilogram, yep. 30,000 and 30,000 cancel each other, yep. What is left? 4 Newton per kilogram or 4 meter per second square. This is going to be the acceleration of the okay. So again, we identify other forces as well, but we didn't need to use those. Okay, but it's help us to picture the problem and understand the problem better. Okay. So I think you can do the next problem, okay, by your own. Okay, so I think we have solved enough problems. Oh, you were writing?
I'm with-
So I'm recording this, okay, and it will be available in your D12. Now I will be uploading this in your D12, the link. I will try to do the same thing every time just in case if, it is highly recommended to come to the class. Just in case if you couldn't come to the lecture class, I try to record and then I will upload and you can watch the recorded. Okay. Example, so I said that, and we just talked about the Newton's third law, defining your system. Defining system. It is really important in physics how you are analyzing a motion of one particle or system of particles. What is the system? System is a
Yeah,
what is the EM?
this is
Okay.
more or less, right? It's summation of all the forces.
Yeah, okay, we don't want to make it come. Yeah, definitely, you are right. Because we have, big force, small force, okay, so, and the combination force of gravity, okay, and the nuclear forces, but we are just talking about the mechanical forces here, okay? Just mechanical force. But we know that we have electric force as well, okay? But we are just talking about the mechanical force in this unit. So the system, when we are analyzing a motion of a particle, sometimes we have just one object. We need to analyze the motion of that object. Sometimes we have a more than one object. So if we have more than one object, we need to define a system. System, we use the system to analyze the motion of particles. When there is two particles, we can say that we have two system, okay? Two particle, two system. Particle number one, particle number two, analyzing the motion of each one separately. Or we can say these two particles are in one system. We are analyzing the motion of these two particles in one system. It means that these two particles, they are attached to each other. Okay? That's why, we have a system. See here, there is a two object. One is pulling the another one. And we can say, when we analyze this motion, we can just put these two and even three objects in one system and analyze the motion of the entire system. Or we can say, no, I would like this to be my object of interest. I don't care what exactly happening to this object. Good. So why this is important? This is important here. cannon and cannonball. Okay. Cannon, when you fire the cannon, how we can analyze the motion of the cannon and cannonball? If we put both in a one system, or if we just put cannon in one system and cannonball in a separate system. Okay? So I would like to do this separately, analyze this in two different systems, ball and cannonball. Good? Let's see what happens. Okay? So let's say this is the, we can put, how we can draw the system, put the closed dash line, okay? Closed circle or dash line, doesn't matter. So this is gonna be my cannonball, okay? And let's say this is gonna be your cannon, yes? So first, I would like to analyze the cannonball forces. How many forces we have?
2, 3,
Okay,
4.
2, 3, 4. Which one?
2,
Four.
3. I don't know.
Emily.
I know gravity.
Perfect. Let's go do one by one. Force of gravity, pushed out. Okay. So what does it mean? Cannon fire the cannonball. Cannon exerting force on cannonball. We call this F. And cannonball exerting exact, Newton's third law. When we have two objects, yes? Cannon exerting force on cannonball exerting exactly the same force, on the cannon, but in the opposite direction. Yep. We already identified one of the forces which is exerted on the cannon. Okay? So but now we are analyzing the cannonball. So force of gravity, and what is the other force? No, there is no, yes, normal force. Why? Because the cannon, okay, the cannonball is still inside the cannon, yes? It is on the surface. See here? Okay? And then exerted normal force. When it is out,
I found this on the web.
when it is out, okay, it's gonna be force of gravity and perfect resistance. See how beautiful is when you just analyze step by step. When it's inside the cannon, normal force, but when it's coming out, yes, it's just still moving it straight. Yep. Definitely there should be a force. What is this force? Air resistance. Okay. So we analyze all forces which is exerted on the cannon ball. Now we need to identify forces on what color I can use that you can see better. This one. Again, normal force because it's on the ground, yes. Force of gravity. And we already identified this. Okay, we said that the cannon exerting force on cannonball exerting exactly the same force on the cannon. Okay. I said I am analyzing these in two separate systems. You remember person on the ground? When you were walking, how I identify forces? I identify forces which is exerted on a person and identify forces which is exerted on the ground. I analyze in two different systems. Yes, I just do the same thing here. Okay, so what I say this is a cannon and this is a ball, cannonball. How many forces? Force of gravity, resistive force, and sorry, not force of pulling, force of gravity, and this is normal force, yes, force of gravity, and good. And I can analyze this one. Okay, I can write the Newton's second law for ball. So what is the ball? A ball is going to be net force divided by mass, yes. A of the cannon, yes, is going to be net force divided by net force divided by mass of the, so this is the mass of ball, yes. Oh, why I cannot write? Okay, system is loading. Okay, mass of ball, yes. And this is the mass of cannon. Good. The net forces, net forces. We don't care about the vertical forces, yes? Because they are canceling each other. Okay? We already know. We are analyzing acceleration in the horizontal. So what forces is exerted on the cannonball? What is the cannonball forces? Positive m divided by mass of the ball, yes? What is the forces exerted on the cannon? Still negative, perfect. Divided mass of the cannon, yep. Okay. Now we have the A of ball, A of cannon, yes? This is positive m divided by mass of ball. This is negative m, the same forces, yeah? Divided by mass of. See how I analyze this? Identify forces, separate these two from each other, okay, and then apply Newton's second law. Good. So which one accelerate more? Perfect. You know, see here, the net, you know, on the top, we will see the same forces, but with different direction. But the magnitude, when we are talking about the magnitude, they have the same magnitude forces on the top, yes? On the bottom, mass of the ball, mass of the cannon. We know that the mass of the ball is much smaller than mass of the cannon. When we compare these two acceleration, what we get? We said that acceleration of the cannon is much smaller than the acceleration of ball, or the ball will accelerate more, okay, travel 1 mile, 2 mile, but the cannonball just couple of centimeters or 1 meter back. See, this is how we analyze. Okay, so we define the system of the particle, and two object, two systems. And we use this system and we analyze the dynamic of the motion by using the Newton's first law, second law, and third law. Okay? Okay. If we say that this is a one system, let me just draw it. Now I have to draw it. So let's say this is a cannon. Good. And this is a cannonball. And then I just say this is one system. Okay. So again, normal force of gravity, normal force of gravity. This cannon exert force on the cannonball. Cannon exert the same force on cannonball exert the same force on cannon. Yes. We just analyze all forces, yes, in one system. When we are adding forces, yes, we are adding force together. We said that in this system, how many upward force? Let's say this is the FG of 1, FG of 2, N1, N2. Good? One system. How many upward force we have? N2 plus N1. Good? Plus. How many downward forces we have? 2. Negative FG1 plus negative FG2. Yes? These are all net forces in vertical. Good? Okay, what is the net forces on horizontal? One to the right, yes? Plus exactly the same thing to the left. So when we, this is important, when we just put them in one system, Newton's third law considered as the internal forces. Good? Considered as the internal forces. They cancel each other. Good? Because we are analyzing this in one system. Okay? And it is up to you which method to analyze the motion of or dynamic of the moving particles. You can use as one system or you can use as a separate system. When you use as a one system, the net force of the entire system in the horizontal direction is 0. But when separately, yes, one is exerting to the right, one being exerted, one receive force in the right direction, the other one exert force in the left direction. That's why this is moving forward, cannonball moving forward, and cannon move backward. But when we said that one system, the net force of the entire system in the horizontal is going to be 0. But they are moving. Each one is moving. Yes. Okay. So we are done. Okay. So we didn't have time to go over the back and forth, but I will try to, if we have time, okay, I will try to go over the back and forth motion analysis Thursday. But please, 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 Thursday, review the Newton's law of motion and come to the class prepared.